Hello everyone. Today our lesson will continue again with the same topic, which is communication network, how the data transfer from one computer to another computer using the internet, or from country to another country, or from city to another city. We spoke the week before about network and communication, like full data about it. Today we will continue at the same topic, but now we're going to talk about how data is transmitted across the networks. So switching techniques are used for transmitting data across network, and there is three types of network are there. We have messaging, packet, and also we have circuit. So circuit switching, message, and packet. Circuit switching, a physical connection between two computers is established, and then the data is transmitted from one computer to another, from the source to the destination computer. Like let's say from point A to point B. This is how data transfer. When computer places a telephone cell, the switching equipment within the telephone system seeks out for physical copper path for a sender to receiver telephone. As we see here in this figure, we have end-to-end connection between computers. Let's say here, this is the end and this is the end. So from here to here, it goes through A, B, C, D. This is how the packet or the message will be sent from A to B, or let's say from A to Z, and again from Z to A again. But it depends who's going to send first or who's going to receive first. So this is, let's say, this is the sender and this is the receiver, but again, it's end to end. So this might be the sender and this might be the receiver. It sets up the end-to-end connection between computers before any data can be sent. Message switching. We have here four lines actually, A, B, C, D. So the message goes from here to here, and from here again to here. And again, it can be from here to here or to here. So the source sends the data, the switching office first, which stores the data in its buffer. Second, it then looks for a free link, as we see here, free link, to another switching office, and then send data to this office. Process is contained till the data is delivered to destination. So the process will contain from here to here until the data is transferred to this last destination. So from this destination, the message will be transferred to this one through these messages packet. This is what we mean by message switching. We switch from here to here and from here to here until it receives to the last destination. It also known, this one, message switching, it's also known as store and forward technique. So these are the technique for message switching. From message here, it transfers to here and transfers to here, and this is, we call it store and forward technique. Now we have packet switching. There is a tight appear limit and the block size. In the message switching, there was no appear limit. Again, we have a fixed size of packet is specified. All the packets are stored in the main memory. So all the packets will be stored in the main memory in a switching office. In message switching, packets are stored as a link in a disk. It stores as a disk. So this increases the performance as access time is reduced. We have transmission media for communication channel. So we're going to talk about the communication channel, the transmission of media over communication channel. We have guided media, cables, unguided media. We have waves through air, water, or vacuum. Example, microwaves or radio waves or satellite. Now I will explain what cables that we are using through the internet to transfer data through the internet. It can be also unguided water, waves, water, air, radio wave, and satellites. Cables. We have unshielded twisted pair, UTP cable, shielded twisted pair, we have STP cable, quadruple cable, fiber optic cable, and wireless LANs cable. So one by one, we will explain what are these cables that we are gonna use in this course. First one, unshielded twisted pair, UTP cable. Twisted pair cabling come into two varieties, shielded and unshielded. Unshielded twisted pair is the most popular and it is generally the best option for school network. So we use this in the school, this cable. This is the picture of it. It has 8 wire, 1, 2, 3, 4, 5, 6, 7, 8. So this is the unshielded twisted pair. Shield twisted pair, the disadvantages of UTP is that it might be subscabled to radio and electrical frequency interference. Second, we have shielded twisted pair. It is suitable for environments with electrical interference. However, the extra shielding can make the cables quite plucky. And the last one, shielded twisted pair, is often used on the network using token ring topology, which I'm going to show now. What does this mean? First cable we have quadruple cable. As we see in this picture here, this figure, this one, it's a quadruple cable has a single copper conductor as it is center. As we see here, it is center and its conductor at it is center. This one will be a plastic layer, provide indentation between the center conductor, between this, and the braided metal. So this one will be in the middle. So this is the center. This one will be a middle layer, plastic layer. And the third one will be the metal shield, helps to block any outside interference for fluence, lights, motors, and other computers. So this is the function. So if I ask you for the function of this or this or this, you will find it here as it's pointed to each of them. And this will be the outsider, provide the ground. So this, let's say it's only the cover of the cable, of the quadruple cable. So cover layer, the plastic layer, and the center. This is what quadruple cable made of. Optical fibers, let's see here. Fiber optic cabling consists of a center glasses core surrounded by several layers of protective materials. As we said before, like quadruple cable is the same thing also, but these are different or tiny or smaller. So the difference all between them, it connects or send the data fast or not fast, slowly. So it depends on the cables or the internet or the satellite. So this are the cables. It transmits light rather than electronic signals. So it transmits light rather than electronic signals. The problem of electrical interference, this makes deal for a certain environment that's causing a large amount of electrical interference. And last, has also made it the standard of connection network between buildings due to immunity to the effects of music and lighting. Now we will come to wireless LAN. As we see here in this figure or this picture, we see here a wireless between 2 computers or 5 or 6 or between country to country, but this wireless only for local, let's say for like home or lab. So only this wire will connect 1 or 2 or more than in the same place because it's LAN. So LAN means like for small place or small area. So not all networks are connected within cable. Some are not connected with wireless. Not all computers are connected by cables. We can connect it by satellites or microwaves or let's say wireless, as we see here. Wireless LANs use high frequency radio signals. So one, it uses high frequency radio signals, interfere light beams or a laser to communicate between the workstation and the file server or hub. So between the file server and the hub or the hub, each workstation and the file server and the wireless network has some sort of transmitter antenna. So each wireless has an antenna to send receive data to make the signal better for sending and receiving data between sender and the receiver. So this is what wireless LAN means. For a longer distance, wireless communication can also take place through a cellular telephone technology, microwave, as we said before, transmission, or by satellites. Wireless networks are created for allowing laptop computers or remote computers to connect to the LAN. Wireless networks are also beneficial in older buildings where it might be difficult to or impossible to install cables. So let's say in a place that we cannot install fiber in it, or like small offices into each other, we cannot put all the cables into these offices to make like a lot of cable in the office. So what we do, we use wireless to connect all the computers together. So through wireless, you can connect to the internet by logging into one company or another company that you like for better internet in your place. So connecting to the wireless, and you will connect your laptop or your computer or desktop to internet to send or receive data, or let's say to send or receive hardware and software through internet or through the network. Types of network, we have LAN, MAN, and WAN. LAN, it's a local area network, which is only for a small area. WAN, it's for wide area network, and this one, it's only for like TV or satellite. One by one, we'll explain all of them now. What is the type of networks that are usually used? Local area network, LAN, L-A-N. It's a network that contains to a relatively small area. So let's say office, lab, one building. This is what we say by LAN. And it's generally limited to graphic area, such as writing lab, school, building. Rarely are LAN computers more than 1 mile apart. So within only 1 mile, or like 1.6 kilometer. In its typical LAN configuration, one computer is designed as file server. So one computer is designed as a file server, and it stores all the software that controls the network, as well as the software that can be shared by the computers attached to the network. So, as we said, small area, lab, school, buildings, and we have here again one computers as designated for file server. It stores all the software that attached to this network. Computers connected to file server also are called workstation. So that's what we mean by workstation. All the computers are connected to this computer, to the server. One of the most line cables are used to connect network interface card in each computer. So in order of you to connect to the internet, you must have a network card into your computer, your laptop, desktop, anything. You must have a wireless or network card in order of you to connect to the internet. Main, spread over a city, example of it, cable or network, and the purpose is to share hardware and software among its users. Now we become to WAN, which is the wide area network, and it's wide. That's mean from city to another city, or from, let's say, India into India, or from India to USA. So it covers the wide, it covers the whole world. This is what we mean by WAN, wide area network. So it is larger graphic area So the difference between WAN and LAN, this one is larger. LAN, it's smaller graphic area, such as India, as I said, or United States, or the world. So the detected transmission cabling or satellite and links might be used to connect this type of network, connected through public networks such as telephone lines, lace lines, or satellites. And it is largest one, it's the internet. So this is one example of one, the internet. Here we have LAN and WAN. Difference, diameter of not more than a few kilometers and span entire countries. So this one is small area, as I said before, and this is the large area, like forward. Operate that at data transfer rate of server megabytes, 1 to 10 megabytes. Here only less or equal to 1 megabytes. 3, we have completed ownership by a signal organization, and here owned by multiple organization. 4, we have very low error rates, and we can have here many higher error rates. So these are only, this table shows us the difference between LAN and WAN. Topologies, the pattern of interconnection of nodes in a network is called topology. So the interconnection, the pattern of interconnection of nodes, we call it topology. What do we mean by topology? Bus topology, we have one here, one example, as we see here. Nodes, this is the file server. This is, I said before, we need to make a computer for the file server to save the data between, or the software between these computer into this file server. A linear bus topology consists of a main run cable with a transmitter at each end, as we see here, at each end. All nodes, file server, workstation, and presets are connected to the linear cables. So all of them are connected to this cable, and each one has a part of this cable in order for you to get connected to the internet using bus topology. Advantages of linear bus topology: 1, it's easy to connect a computer or a versal to a linear bus, requires less cable length than a star topology. And disadvantage of a linear bus topology: entire network shut down if there is a break into the cable. So if this cable get cut here, all the computers will shut down, or the network, I mean, it shut down. So you won't be able to send or receive data unless the cable is fixed. The transmitter are required at the both end of the backbone cable. Difficult to identify problems of if the entire network shut down. Nodes must be intelligent. Each node is directly connected to the central bus. So each of them are connected to the server bus. Here we have the star topology. We have a hub. So this hub are connected to node 1, node 2, node 3, node 4, node 5, and they can transfer or send data to each other through this hub. So by this hub, we transfer or we send, receive data or files, hardware, software through this hub, as we see here as well. So that's why we call it a star topology. It looks like a star, 1, 2, 3, 4, 5. So we call it a star topology. A star topology is designed to, with each node, file server, workstation, and participant connected directly to a central network hub or connector. So this one we call hub or connector. Data on a star network passes through the hub or connector before containing the destination. So it passes, if I want to send from here to here, so it has to pass from here to the server, or to the hub, I mean, to this one. Again, from this one to this one, or from this one or to this one. So this is how it goes through the star topology. So it has to go through the hub. Data in star network passes through the hub or connector before continuing its destination. The hub is connector managing and controls all the function of the network, and it's also a repeater for data flow. So we can send from here to all of them, or we can send from here to all of them. So this is what we call data flow. Advantages of a star topology: we have easy to install and wire. Second, we have no distribution to network when connection or removing devices. Easy to detect faults, to remove bats. Disadvantages of a star topology: we have require more cable length than a linear topology. If the hub or connector fails, nodes attached are disabled. More expensive than a linear bus topology, bus of the cost of connectors. So each one of them, like star or the one I said before, the bus topology, has advantages and disadvantages. But it depends how do you want your data to be transferred from computer to computer, or how from a connector or bus topology by using a bus or topology, star topology. Here we have again a ring topology. Ring network, a local area network formed a ring, as we see here, like a circle. This one we call a ring, that use a token passing as a mean of relation, traffic, and the line. On the token ring network, a token governing the right to transmit is passed from one station to the next one by physical circle. So it goes to from here, let's say for this one, or again from this one we have to send to this one. If the station has information to transmit sizes, the token marks it as being in use and insert information. The busy token plus message, it is pass around the circle. As we said before, it passed around the circle and return to the sender. The sender removes the attachment message and then passes to another station. Advantages of ring topology: we have short cable length as compared to star, no wiring, closet space required, suitable for optical fibers, high speed traffic travels in one direction. So this one is very important. It goes only in one direction, as in bus topology. Disadvantages: we have node failure, causes network failure, difficult to diagnose faults. Network reconfiguration is difficult and not possible to shut down a small section of the ring. Now we have here a 3 topology. It looks like a 3. That's why we called it 3 topology. From backbone cable, we have here endpoints, and we have the 3, like the roots of the tree. A 3 topology combines the characteristics of linear bus and the star topology. So it's combined of a linear bus and the star topology. It contains of a group of star configures workstation connected to the linear bus backbone cable here. 3 topology allow for the expansion of exciting network to enable schools to configure network to meet their needs. Advantages: point-to-point writing individual segments, supported by several hardware and software vendors. We have disadvantages: overall length for each segment is limited by the type of cabling used. If the backbone lines breaks, the entire segment goes down. More difficult to configure and wire than topologies. We have consideration when choosing a topology. First of all, we have to, let's say, plan. We skip this one, which one we are going to use, bus, start, or 3 topology. Then we are considering the money. how much is our budget to use or to install in our, let's say, office or in my workstation. And then we have to consider the length of the cable needed. 3, we have the future growth and the cable type. So the money, let's come again back to the money. Linear bus network might be the last expensive way to install a network. You don't have to purchase connectors or switches or hubs. Length of cable needed, the linear bus network use a shorter length of cables. Future growth, with a star topology, expanded a network is easily done by adding another connector. And here again we have the most common cable in the school is unshielded twisted pair, which is the most often used with the star topology, and this is for the cable type. Network device, we have modem. Modem are the most frequently used to enable computers to communicate with each other across the telephone lines. So through the modem, we connect computers to communicate with each other through this modem. Stand for modulation, demulation, and convert digital signal to a long single signal and vice versa. So sender receiver, receiver to sender by digital signal. 2 types, internet and external, internal and external. We have here RG45 connector, this cable. Register jack 45 is an 8-wire connector. So each one, this cable has 8-wire connector and is commonly used to connect computers and LAN. This one. So what are discussed today is how to connect computers to each other. As I said before, we can connect it through wireless cables, microwave, satellites. So in order to transfer data between computers, or let's say country to another country, or from sender to receiver, or again from receiver to sender, we have to have a switch or a hub or star topology or bus topology, or we need to have let's say a plan to transfer data between this, but through a modem or through cables. It can be satellite, wireless, anything to transfer the data between them. That's what we mean by talking about network or communication. So by this type of let's say cables or network, we can transmit the data. So you save money, you save time. So if you go to the mail office or the post office to send one email to your friend in one other country, it takes you time to go to the post office, and you have to write a paper, and then you have to buy a stamp, let's say, and send it, and pay money to send it. And it takes, let's say, for 1 week to receive the data in another country, the email. So by using communication, you can send it within 5 minutes or 1 minute, sending the data between your friend, you and your friend. So by using communication, the world becomes smaller. And this is what communication and network means. Thank you very much for the day, and I hope see you for next week.